All right, we'll get started in a minute, but your notes are on the board here. It's really not hard. It's just paying attention to what you're doing. And if you've been doing things and writing things down the way that I do them, you're going to have no issue with this at all. If not, just pay attention to what you're doing and you should be fine. But we are solving two-step inequalities today. So you're going to treat most of these like they're equations and solve them as two-step equations. But today we're looking at two-step inequalities. First thing you're going to do is, when solving these, treat your inequality sign. And again, your inequality signs include that, 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 and technically this, but this isn't going to work. But here we have less than, here we have greater than. This means less than or equal to. So if it has a line underneath, its possibility to be equal to. And here you have greater than or equal to. So these are your inequality symbols. They replace your equal sign when you do problems. So for example, if I were to do this problem example here, but as an equation, right, 2y minus 3 equals negative 5, right, this is what we've been doing all week. Add 3 to this side, add 3 to this side. Because we're doing order of operations in reverse, you get 2y equals, and then negative 5 plus 3 gives you negative 2. And then you divide this by 2, divide this by 2, and you get y equals negative 1. That's if it was an equal sign. Today we're looking at them being inequalities. So how does all of this change if this is an inequality symbol as opposed to an equal sign? Well, the first thing you should note is that inequalities have an infinite amount of answers to them, unless you restrict their domains. But there is an infinite amount of possibilities for y here. So if I plug something in for y, there's an infinite amount of numbers I could plug in that would make this statement true, because this side here just has to equal less than negative 5. So for example, you could plug in negative 10 in there, and then 2 times negative 10, well, we can go ahead and do it. 2 times negative 10 minus 3 has to be less than negative 5. Well, this is negative 20 minus 3, which is negative 23. Negative 23 is less than 5, so negative 10 is an answer. You could put negative 11 in there, and you can get negative 22. And this would be, well, you'd still be subtracting 3, but this would be 25 now. So negative 11 is also an answer. And then any number between these two, like negative 10.1, negative 10.2, negative 10.00005, any of those numbers are technically answers to that problem, because it's an inequality. We just want things that don't equal it but are less than. So our goal is to figure out what is the highest or lowest number that I could put in there, depending on what your inequality is. So I want to be, what is the highest number that y could be here for this to be true? That's what I need to figure out. Once I figure that out, I can be like, well, the number is 5, and anything less than 5 works. But I want to figure that out first. And how to do that is really simple, actually. You're going to treat this inequality like an equal sign. So you're going to solve it like this is an equal sign, like we just did. You're going to solve it like that's an equal sign. So we're going to go ahead and draw our line down here. And remember your algebra, whatever I do to one side, I have to do to the other. And I want to get y by itself. So over here, order of operations in reverse says I want to get rid of this subtracting 3 first. So I'm going to add 3 over here. And I'm going to add 3 over here. That's not going to change much. It's just going to say, hey, I'm going to get rid of the minus 3 over here and include the minus 3 to this side. It's not going to change anything. It's just moving it over. So that's going to be left with 2y. And over here, we still have this inequality symbol instead of an equal symbol. and we have negative 5 plus 3, which gives you that negative 2. Now, things to take in consideration when you do multiplication and division, because this is where our exception comes from. The only thing you really need to pay attention to is when you are multiplying or dividing by a negative number. So here, if I divide this by 2, I'm not dividing by a negative number, so I don't have to worry about anything. I'm dividing it by a positive 2. This is the number I'm looking at. Whatever number I write down here, that's a positive, so nothing's changing. In doing so, I'm just going to solve it out. This becomes y because these will cancel. And negative 2 divided by 2 gives me negative 2. Or I'm sorry, negative 1. So y has to be less than or equal to negative 1. And there are a couple ways that you can write your answer. And I would like you to do both, however, I'm only going to see the one. And that's like this. The best you can. Using docs, there are ways to get these inequality symbols, especially if you go into the equation bar. And I can show you that once I do a couple of these problems with you on how to write them. But here, there are two ways that I would like you to write your answer. One, I would like you to write it as your inequality. This is what I'm going to see. So your answer is y is less than negative 1. So any number less than negative 1 is going to make this true. I'm sorry, less than or equal to negative 1. So if I plug in negative 1 here, it actually equals negative 5, which makes it true because it has this line underneath, which means equal to. So if I plug in negative 2, this would work. However, if I plugged in 0, this would not work, right? Because 2 times 0 minus 3 equals minus 3, which is not less than or equal to minus 5. Minus 3 is a larger number. So 0 does not work. It doesn't fit that criteria. However, anything less than negative 1 or negative 1 will work. The other way that I would like you to start writing them is to actually graph them. And we graphed these a while back, if you recall. But you're just going to look at this. This isn't equals to. You're going to graph it on a number line. So what I need you to show on the number line, again, I'm not going to see this. You just need to know how to do it. Because I'm not sure the best way for you to send me information about graphing, unless you take pictures, and pictures kind of tend to be tough to read. And we need negative 1. I'm going to stick in the middle of my number line because that's the value I'm concerned with. And we have a number on this side, which would be negative 2, and a number on this side, which would be 0. So you see my little section of the number line here. I'm concerned about negative 1. Because this is equal to, remember, greater than or equal to or less than or equal to give you dots, while less than or greater than give you circles. So I'm going to put a dot, because it's one of these two signs, on negative 1. I'll do that in a different color. So my dot goes on negative 1. And which direction do I want to shade? Well, does 0 work or does negative 2 work? When you plug it in here, is 0 less than or equal to negative 1, or is negative 2 less than or equal to negative 1? Negative 2 is, so I shade it this way. And that's how you graph them. This is what I want to see. Right, this here is graphing, which I'm going to take your word on it that you're going to do. But they are the same answer. This is just a visual saying that, hey, it includes negative 1 plus everything to this side of the number line of it. And that's what we're looking at. I'm going to do another example, and hopefully this is one that, I didn't try this yet, but hopefully it's one that involves a negative here. I'll leave all the notes up there. Our example here is, let's do negative 9 is greater than negative 1/3 x plus 6. And you're going to look at this and you're going to solve it using these kind of steps. Just be aware of this. Whenever you find yourself multiplying or dividing by a negative number, you need to flip your sign. That's the only difference. So we're going to continue like we do normally. Whatever I do to one side, you got to do the other. The variable is on this side, and order of operations in reverse. You see how I have the plus 6? I'm going to do minus 6. So minus 6 here and minus 6 here. I am not multiplying or dividing by a negative number. I am just subtracting a 6. No multiplication or division in there at all, so I don't have to worry about my sign doing anything weird. So the sign is just going to come down. Over here, my 6's will cancel and leaves me a negative 1/3 x. Over here, negative 9 minus negative 6, watch your integer operations. Signs are the same here, so I'm going to add them and keep the sign. That's going to give me a negative 15. Okay. Next, I need to get x by itself. In order to do that, I need to divide this side by a negative 1/3. And I'm going to do the same over here, negative 1/3. You will note that this is what I'm looking at. This is a negative number. So I'm dividing by a negative number. In that case, the only difference this is going to make, and you got to watch for it, is that this sign here is going to flip directions. So it's going to be that now. Other than that, it's handled normally. Same thing you've been doing. I'm now going to cancel these out. It leaves me with x over here. And then negative 15 divided by negative 1/3. You know these are both negatives. So your answer right there is going to be positive either way you look at it. Here you got 15 divided by 3. I'm sorry, divided by 1/3, not divided by 3. Divided by 1/3, which again, if you get confused with that, it's going to be, and I'll write it like that first, 1/3. It's going to be multiplying by the reciprocal. So it's 15 times 3 here. And that's going to give you 45. Oh yeah, how to write it? You can write it like 45 is less than x. So any number that is larger than 45 will make this statement true. So this is what I want to see, and then I would like you to graph it as well. So on your number line, in this case the number I'm concerned with is 45. One number less than 45 is 44. One number more than 45 is 46. It is going to be an open circle because it's one of these two signs, so I'm going to circle where 45 is. And then it is 45 has to be less than x. So plug in 44 and 46 into x and see what it makes sense. Does it make sense to be 45 is less than 44 or 46? Well, 45 is less than 46, so I want to go in this direction. And I shade in this direction. And those are your answers, yeah. If you follow along a little bit here, let's look at a number line. Let's say 0 is here, and let's say let's get a big number. Let's say 100 is here. So yeah, I can do 3 as another example, John. But let's just look at this first. And let's say, hey, if I multiply 100 by a negative number, what happens to it? And if I multiply this by a negative 100, Okay, so 100 times negative 100. Or actually, let's just do negative 1. That'll make life easier. Right? If I multiply this by a negative number, so negative 1, what that's going to do is it's going to put me at negative 100. Right? Because this equals negative 100. That jumps all the way to the opposite side of your problem. Right? And if I go ahead and do the same thing on this side and I multiply this by a negative number, it jumps it to that side of the thing. So what doesn't matter about the original number, it matters about what you multiply or divide it by. It's going to jump it to the opposite side of the number line, which means your inequality is going to have to flip to account for that jump. Same thing's going to happen if I do division. If I divide this by a negative 1, this is now a negative number, so it jumps to this side. If I divide this by a negative 1, this negative number went to become a positive number, so it jumps to that side. That's why it only happens when you multiply or divide by negative numbers, because it has to account for that jump to the opposite side of your equal sign. When you multiply by positive numbers, right? If this was multiplied by a positive 1 or divided by a positive 1, it would stay positive. Right? So you're not changing it. This was multiplied or divided by a positive 1, it would stay negative. So it doesn't change the sign. So it only happens when you multiply or divide by negative numbers. So let's look at number 3 as another example. Number 3 says 10 plus 4a less than negative 6. So again, I'm going to treat this just like that's an equal sign. And I'm going to do all the algebra stuff I've been doing all week, just pretend that's an equal sign. But I'm also going to be paying attention to if I ever multiply or divide by a negative number here. So I'm going to bring this 10 over. That's a positive 10. So I'm going to subtract 10. Watch your integer work. This is going to cancel, leave you with 4a. 16 minus 10 gives you a negative 16. Then I'm going to divide by a positive 4. Divide by a positive 4, so my sign isn't going to change. I'm sorry, this is still this sign. Sign's not going to change because that's a positive 4. This leaves me with a, and this is a negative 4. So your answer is a is less than negative 4, and to graph it, negative 4, 1 less would be negative 5, 1 more would be negative 3. It is a circle because it's one of these two signs, and it is shaded. Well, is negative 5 going to work, or is negative 3 going to work? Negative 5 is less than negative 4, so it's going to be shaded this way. But again, this is what I want to see. You should be able to graph it though. Any other questions? Fairly simple assignment. Just watch out for when you multiply or divide by negative numbers. Let me see if I can find another one that has a negative. $12 should, I think. So again, this one will have a negative, so we should be flipping our sign here. Again, solve it just like it's an equal sign. So we're going to add 6 here and add 6 here to get rid of this subtraction of 6. So that cancels and that cancels. Sign didn't change because I was just adding 6. I wasn't multiplying or dividing by a negative. So this leaves me with negative 8x, and over here I have 16 because 10 plus 6 is 16. Then I'm going to divide each side by a negative 8, and there's your division by negative. So right here, you're dividing by a negative. Right? So this sign is going to flip So it was pointed towards the 16. It now points this way. It's still going to have the equal part to it. When you solve this, you're going to get a negative 2 over here, and you're going to just get x. So your answer is negative 2 greater than or equal to x. Just so you know, you could have also written that the other way, but if you flip it, all of it, you got to flip everything. So if the x is coming over, then the sign is flipping as well when you write it this way. Think in mind that the mouth is still eating the negative 2, so it has to eat the negative 2 still. So those are both ways that you can write it, depending on whatever you're more comfortable with. And then when you graph it, negative 2's there, we want negative 3 here, negative 1 here. It is a dot because it has the equal to sign underneath. So I'm putting a dot there. And you can ask yourself, is negative 3 a good answer or is negative 1? So is negative 2 greater than or equal to negative 1? Not really, no. Negative 1 is the larger of the number, so you're going to go with the 3. So we shade towards the negative 3. I flip the sign because whenever I multiply or divide by a negative number, I'm going to flip signs. Here the sign flips because I flipped everything. So these are the same statements. Again, if I put in a negative 3 here versus a negative 1, how would that graph? I would still be on the negative 2, negative 3, and negative 1. I'd still have a dot there. What is better? Negative 1 is less than or equal to negative 2, or negative 3 less than or equal to negative 2? Well, negative 3 is less than or equal to negative 2, so I still shade this way. So they are the same. They're just different ways of writing it. Inequalities aren't too difficult. They just take a little focus. And again, if you've been writing things the way I've been, you should note that, hey, here's our division by negative number. It's really easy to point out. How did I get negative 2? Because 16 divided by negative 8 equals negative 2. I can walk you through it all again too. That's not working for you here. Here it goes. Let's do it back. That was a minus 6 there. So again, I'm going to treat it like it's a normal equal sign. Add 6 to both sides. This gives me 16. It's actually this symbol, not an equal sign. And 8x divided by negative 8 divided by negative 8. So here, this here is your division by negative. So my sign has to flip. So it's going to be that. This leaves me with x. And the 16 divided by 8 gives me that negative 2. Watch your signs. Does anybody want me to do any more examples? Your assignment is up here. There is a little answer sheet on Google Docs to submit it in. You want to look at 22 real quick, just don't forget to distribute. Combining like terms and distributing is nothing different. It's the same as what you've been doing. So you get, oh, that's actually going to be negative. 4 times that is negative 28. And then you can go from there. What is that, 40? I'm sorry, those are different signs. Subtract them and you get 16. And here's your negative. So that becomes A is negative 2. That's an A. Yep. Not simple. That's all there is to it. So give that a shot. If you have questions, you can email me. But that's what you should be working on. Somebody wanted to do... Oh, I'll show you how to get inequality signs if you don't know already. So here's your answer sheet. What was number 3? Number 3 was... Three equals, or I'm sorry, it doesn't equal. The answer to 3 is A is greater than negative 4. So that's the answer to number 3. A is greater than negative 4. I'm just going to hold that over here. I'll show you how to type that in. If you click on here, you can go to Insert Equation. And you can type in this little box. You can do A, and then all your inequality symbols are right here. So whichever one you want, with the exception of that and that, which are keyboard keys. So you can do that. But if you wanted, there's that symbol, so you can get that symbol in there, and there's that symbol, so you can get that symbol in there. But yeah, you just type in a little equation box. And you can mess around with it. You get all your other stuff in there too. You got your Greek letters, you got your set theory, you got your inequality stuff, you got your fractions, radicals, exponents, derivatives, and integrals, and just yields. So that gives you a few more different notations if you don't know how to do this. But other than that, you should be working on that for the remainder of your math class today. If you have questions, shoot me an email. I can do a couple more for you if you need any now, if you mention it. But other than that, you're on your own. Submit it by the end of the day, or really by tomorrow's math class. And you should be off to a pretty good start. Tomorrow, you're looking at compound inequalities and how to graph them, which really is not much different, but you're going to get things like negative 3 is greater than equal to x, which is greater than or equal to 10 or something like that. How to graph things like that. So that's not too difficult. And we'll go over that tomorrow. So if there's no other questions right now, I'm going to get off, leave you to it. If you do come up with a question, shoot me an email and I'll make you a little video explaining how to do it. So with that, thanks and so long.